Hey everyone, it's Chaz. Welcome back to the channel. In this video, we are returning to LeetCode problem 51, N Queens. This is a two-part video, and you are currently watching part 2. In part 1, I presented a visual explanation of how to solve N Queens. So if you haven't seen part 1 and you want to see an explanation of how the algorithm works without any code, then please check out part 1. Otherwise, here in part 2, we're going to actually start to code up our solution. So if you're ready to see how this algorithm looks in the form of Java, then there's only one thing left to do. Let's code some Java. Right, so I've got the problem open here on LeetCode. I'm going to type the solution out in real time and explain what I'm doing as I go. So first of all, I need to return a list of strings. In my solution, I'm actually going to create the recursive method separately from this method where my solution is going to go. Because of that, I'm going to need to be able to access this list of strings. To make things easier on myself, I'm actually going to put that variable outside of this method and just inside the class itself. Right, and what this will do is it'll allow me to access this variable even if I am not inside this method. Before I actually find solutions, I need to represent the queens in a way that's easier for me to understand. So I am not going to represent the queens as a list of strings. Instead, I'm going to use an array. It's going to look like this. So here I've created an int array called queens, and it's just going to be an array of size n. And I wrote a comment up here that I'm using an int array to represent the layout where the index of that array is which row number we are in the chessboard, and the value is going to be the column number where that queen is located on the board. I'm representing the layout like this because it's just easier for me to understand. We're taking advantage of the fact that you can't put two queens in the same row anyway. What this int array of size 4 represents is that the queen in row 0, in the first row, is at index 1, so column 1, and this is if it's 0 indexed. And then the queen in row 1 is sitting at column 3. The queen in row 2 is sitting in column 0, so the very first column of that row. And then the queen in row 3 is sitting at index 2. That's what this array represents. Okay, now I'm going to use recursion. It doesn't really matter what you name the recursive function. I'm just going to call it backtrack. And it's going to take two parameters. I'm going to give it a row number, and I'm also going to give it my queens array. And this array is what will be adjusted with each subsequent call. And then once we perform the backtrack method and we find all of our solutions, all we have to do is return them. So I'm just going to return results. So the goal here is for the backtrack method to use recursion and backtracking to build a master list containing sublists of strings that will represent the chessboard layouts that are valid solutions to this problem. So I'm going to need that method backtrack. So let me create that. And like I said, it's going to take a row number represented as an int and that int array queens that I created. So whenever we're dealing with recursion, we are going to have a base case and a recursive case. In this case, since I'm using backtracking, I'm going to use slightly different terminology. I'm going to have a base case. Instead of a recursive case, I'm going to call it an inclusion case. It's basically when you're doing a problem with recursion and backtracking, you're basically exploring every possible path. So in order to do that, you'll need to include a certain portion of a path. And then if that doesn't actually work, then you should backtrack. Right, so let me start by writing my base case. What I want to happen is that when I successfully place queens in every row, I want to then generate my board and submit it. So let me start my base case. And here I'm saying, since every time I do something in my inclusion case, I'm going to advance to the next row, I want to reach a point where the row number that I pass into this method is equal to the length of the queens array. Like for this example here with 4 queens, if I manage to pass in the number 4, it means I've successfully placed all 4 queens. I'm not actually going to do anything with row 4. It's just a signal to tell me that I've actually found a solution. Now, I'm supposed to make a list of strings with this solution, and right now I have an array showing the locations of all of my queens. So I'm going to need to generate a board using that array. So for that, I'm actually going to use a helper method so that I don't have to type all of that code within this block, because it's going to be a lot of code. So I'm going to call my helper method generate board. I haven't created this method yet, but I will in just a moment. It'll give me a list of strings similar to the solutions that we have here. And once I have that list of strings, I can submit it as a sublist to my master list of results. And then once this is done, usually this will happen a lot in backtracking problems, is once you reach your base case, you actually don't want the rest of the method to run at that point. So you can prevent that by just returning. Another way you can do it is have an else block here and have the rest of your code within the else block. But personally, I just think it's a little cleaner to return. And actually, if you wanted to, since you know that this variable current board is really just the result of generate board, you can actually just put it in the parentheses, and then you don't even need this line. Now let's see what the generate board function is going to look like. So my generate board method is going to return a list of strings. It takes in that int array queens as its input, and I'm making these private. It doesn't really matter. You can make them public if you want. And by the way, I forgot to mention this earlier, but my backtrack method, I have it listed as void because it's not going to return anything. What's going to happen is while this backtrack method is running, once it finds solutions, it's going to add them to that list called results that I created up here. So I don't actually need to return this list because it's being built as I go. And by the time I come out of all of my recursive methods and I'm finished calling backtrack, then I can just return the results from the solve n queens method. I don't have to return it from the backtrack method. So anyway, on to generate board. Let me just add a comment to the top of it so that I know what this method is doing. So this will generate the board layout per the problem requirements. It's going to use a dot for empty spaces and a Q for the queen locations. It's going to return a list of strings, so let me create that. And since I'm creating a list of strings, I'm going to be generating a bunch of strings, and a really efficient way to do that, instead of adding characters to the same string over and over again, it would be a lot more efficient if I used a string builder. So I'm just going to call it SB. And without going into the details of how a string builder works, all you really have to know is that it is faster for adding together parts of a string, like building a string. Literally, that's what it does. It's faster than taking a string and like adding a letter to it. So maybe if you had like a string, something like that, and then you wanted to add additional letters to it, you could go, and this would work. But if I have to do this over and over again, like 20, 30 times, it is a lot faster. It's a lot more efficient to do this with a string builder instead of concatenating strings like this by using addition. I'm going to create a for loop inside of another for loop. I'm going to have the outer loop represent the rows of the board that I'm generating, and I'm going to have the inner loop represent the columns. So let me set that up. As I iterate through the columns of a particular row, I'm going to use the row number that corresponds to the index of my queens array. And then whatever the value is, that's going to be the column where the Q goes. So when I look at my queens array, so just as an example, if I use this image, this second image, as the solution, my array for this particular board would look like this. And so at index 0 or row 0 of my board, the queen is located in column 2. So when the row is 0, so the first iteration of this loop, I iterate through the columns. And so if we're at row 0, column 0, there's no queen there. So I'm not going to place a Q. I'm going to use an else block and say to append a dot in that spot. And then we get to row 0, column 1, no queen, so append another dot. When we reach column 2, the first value of the array is a 2. So when queens at index 0 equals 2, I will place a Q instead. And then when the column is 3, there won't be a queen there, so I would put a dot. And that would end up being this right here, dot, dot, queen, dot. And then that'll be the first string in my list of strings. So I should add that string to my list. And I'll do that when I'm done iterating through the columns, but still inside the current row. So I need to stay inside the outer for loop. I'll add the result of the string builder when converted to an actual string. And then when I go to the next row, I currently have a bunch of characters in my string builder. So I have to start it over again. Now there isn't a method for clearing the string builder. I could just create a new one every time, but it is actually faster. Like a really quick way to clear a string builder would be to do this. So if I take the string builder and set its length to 0, basically what that does is it clears all of the characters of that string builder. And that's actually faster than creating a new string builder for every row that I iterate through. In the example of a 4x4 board, this will run 4 times for row 0, 1, 2, and 3. It'll check 4 columns, columns 0, 1, 2, and 3. When I have a match in my array, it'll draw a Q. Otherwise, it'll draw a dot. And then when this is all done, all I have to do is return that list of strings, which I called board, so I will return the board. So now when this method is complete, I will have a list of strings that I can use in my result. I can just add that to my results list, which is my master list of solutions. So the next thing I'm going to have to try to do, I need to create my paths for my inclusion case. Or essentially, I need to be able to place queens in different columns of the current row. So the current row gets passed into the function. We will already know which row that we are in. It's just a matter of changing the column, trying different columns. So I'm going to do that with a for loop. And so what I'm doing here is in my current row, I'm going to check every column one at a time and try to place a queen there. So I'm placing them using that int array. The int array is called queens, and I'm trying to place a queen in the current row. And where am I placing it? I'm placing it in the column number that's currently represented in my for loop. So set it equal to column. Now, we said that we need to make sure that every queen we place is placed legally. It's placed in a valid spot. We need a way to check that. That is also going to be quite a bit of code. It's going to be several lines. Instead of putting it here within this backtrack method, I'm once again going to create helper methods to do this. I'm going to create more than one. Now we said that queens are attacking each other if they are in the same row, the same column, or if they are diagonal. I don't need to check the rows because since I have this set up as an array where each index represents a row, it is impossible to put 2 queens in the same row. So I only need to check the same column, and I also need to check diagonals. So let me start to write that here. So what I'm saying here is I'm going to create a method called same column. This will check if the queen I just placed in the current row is in the same column as any other queens that are currently in my array. And then I'm also going to create a method called isDiagonal. That's going to tell me if the queen I just placed in the current row is diagonal to any of the queens currently in my queens array. And that's why I'm passing the row number and also the queens array itself. And so what I'm going to say is if the queen I just placed is not in the same column and it is not diagonal from any other queen, that means it's on a safe square. So that means I'm okay to advance to the next row. And how do I do that? I'm going to call this same method backtrack, but instead of calling it on the current row, I'm going to call it on row +1. And I'm going to pass in that same queens array. Right, so now let me go ahead and implement the same column and isDiagonal methods. I'll do that right down here. Right, so let's start with same column. It takes the current row and it takes the array of queens, which gives me the location of all of my current queens. For two queens to be in the same column, we'll come over here. For these two queens to be in the same column, so basically to look like this, for example, even though this board is arranged like a two-dimensional array, my queens array is actually a one-dimensional array where the index is the row number and the value at that index is the column number. But basically, like here in this example, say that each row just represents the index number. So this top row is index 0, index 1. I know it has different numbers down the side, but let's just ignore the chess notation for now. So I have a queen in row 1. Its column is 0, 1, 2. And then I have a queen in row 4, and its column is 0, 1, 2. The value at both indices is the same. And so that's what I'm going to check. And I need to check this for all of the queens before my current queen. And I'm going to do that using a for loop. So for my loop, I'm going to iterate the value I, starting at 0 and incrementing as long as I is less than the row number. So I'm only going to check the queens before the queen in the current row. And I said I was going to check if their values, if the values at those indices are the same. And if I find an index that has the same value as my current index, that means I have two queens in the same column, so I should return true. If I iterate through all the queens and I do not find anything that satisfies this block, so the for loop ends up surviving all the way to the end, that means there are no queens in the same column as my current queen, and therefore I should return false. Now let's implement the isDiagonal method. And you can see here I say that it's explained at the bottom of this class because this one for me was a little harder to figure out. So let me scroll down to the bottom here. But what I did here was I wrote down a few different examples of queens that are on the same diagonal. So all of these coordinates here that are lined up together, so 0, 1, 1, 2, 2, 3, and 3, 4, these are all examples of queens that are on the same diagonal. And I'll show you what that looks like. So if we treat this like a 0-indexed two-dimensional array, then 0, 1 would be here, and then 1, 2, 2, 3, and 3, 4. These are all on the same diagonal. I come back here and I give another example, so 0, 3, 1, 4, 2, 5, and 3, 6. So that would be something like this. These queens are all on the same diagonal. And it doesn't have to only be left to right. It could also be right to left. And that's what this example is. 0, 7, 1, 6, 2, 5, and 3, 4. So 0, 7, 1, 6, 2, 5, and 3, 4. And then the last example I gave is just 0, 0, 1, 1, 2, 2, and 3, 3. These are all examples of queens that are on the same diagonal. So I wanted to see if there was some kind of pattern here. And what I noticed is that the difference between the indices was always equal to the difference between the values. And when I say the difference, I mean the absolute difference. So take a look. With my first set of diagonal queens, if you notice, say I take this queen and this queen. If I do 2 minus 0, that's 2. And then if I do 3 minus 1, that's also 2. And these queens are diagonal. And then the same thing here. Say I take this queen and this queen. 3 minus 0 is 3. 6 minus 3 is also 3. And then let's look at the one that goes right to left instead of left to right. Say I take this queen and this queen. So 2 minus 0 is 2. But 5 minus 7, well, that's not 2. It's negative 2. But these queens are still diagonal from each other. As it turns out, you actually don't need to be concerned with whether the value is positive or negative. You can just take the absolute value. So queens on a chessboard will always be diagonal when the difference between the indices is equal to the difference between the values. And when I say the difference, I mean the absolute difference. So let's turn that into code. So I'm going to need to use a for loop again. What I said is that I need the difference between the indices, and I also need the difference between the values, but I need the absolute difference between those values. So first of all, let's make a variable for the difference in the indices. And that's just going to be the current row number minus I, just whatever row we're checking at the moment. Now let's make a variable for the difference in the values. So I need the values at these indices. So that's going to be... So there's the difference, but we need to take into consideration the fact that we could potentially get a negative. So we need to take the absolute value of this, and we'll just use the math class and the abs method for absolute value. And we said that if these two differences, if these two variables are equal to each other, then the queens are diagonal. So if I find a queen that meets this condition, I will return true. If I get through all of the queens and never find one that's diagonal, so the for loop survives, that means none of the queens in my array are diagonal to my current queen, and I should return false. So let's come back up here to my backtrack method. Now that I've written these two helper methods, you can see why I wrote them down here as helper methods instead of putting them inside my backtrack method, because it would have made this a lot longer and a lot harder to read. So now when you read this method, it's really just saying, when I consider the queen in the current row compared to the rest of the queens in the array, if they are not in the same column and they are not diagonal, then I should continue my algorithm by advancing to the next row. If one of these conditions is not met, so if I find a queen that is in the same column, I want it to be false, but it ends up being true, or I find a queen that is on the same diagonal, so I want it to be false, but it turns out that it's true, then this block will not run. And so what will happen in that case? Well, I'll reach the end of the for loop, so the for loop will increment. And that's exactly what I want. So let's take a look at the chessboard. Let's say I have this situation here. I have successfully placed a queen, and so I call the backtrack method on the next row. In row 2, I have my for loop that starts at column 0. So I place my queen in row 2, column 0, and it's in the same column as another queen. So I needed this to be false. It turned out it was true. So this block does not run. Instead, this iteration of the for loop ends, and so the column will iterate to the next value. We'll go to column 1. This time, it's actually diagonal from a queen. So I wanted this part to be false, but it was actually true. So this will not run. Instead, I will reach the end of this block, and so the for loop will iterate to the next column. It'll move here. This time, same column will be true when we want it to be false. So the for loop will iterate again, and we'll go here, and this time it will find a valid spot because it's not the same column and it's not diagonal. So not same column, not diagonal. So now this line will execute. And I'll call backtrack on the next row, which is now row 3. So that's sort of the happy path. That shows us what happens when we successfully place queens. But if we find an invalid path, or if we find that it is impossible to place a queen in our current row, then what do? So that's when we're supposed to backtrack. The trick here, and what stumped me for the longest time, was trying to figure out what goes here. What do I type for my backtracking part of the method? Oftentimes in these backtracking problems, you're building like a list of letters, a list of numbers, or just some kind of path that involves a list for your solution. And if it turns out that the current element that you just added to the list is no good, you're supposed to remove that element from the list. So I sat here for who knows how long trying to figure out, well, how do I remove the previous queen from my list or from my array? And just on a whim, I just decided to hit submit just to see if I had any compile errors, and my code actually passed all the test cases. So I was like, wait, what? Yeah, it turns out you don't have to type anything for the backtrack case. So let me see if I could explain to you why that is. So let me show you the situation where, say I have a queen here and a queen here. And so I've successfully placed the queen in row 0 and row 1, and then I call backtrack with row 2. So I've called backtrack, I come back here, the base case isn't met, and I come right back into the for loop, but this time I'm in row 2. So I try row 2, column 0. I place the queen, and same column is true. I wanted it to be false, so this block does not run. I reach the end, and column iterates. This time is diagonal is true. So this block does not execute. Instead, I reach the end of the loop, and so column goes up by 1 again. So now it's 2. Same column ends up being true when I wanted it to be false. So column just increases again. And this time is diagonal ends up being true. So what happens now? Well, the for loop would end at this point because column tries to be 4, but 4 is not less than the length of the array because the length itself is also 4. By the way, just for the sake of illustration, let's just pretend we're back in a 4x4 array here. So what'll happen is the entire for loop ends. And what happens at this point? Well, there's nothing else here. So the entire backtrack method ends. So when that happens, where are we? Well, remember, we were in row 1, and then we called backtrack with row 2. The entire method with row 2 just ended. That means we're here. But we're here for row 1's call of the backtrack method. We moved back up 1 level. And so we called backtrack. The method actually managed to complete. So we finished the if block. There's nothing else here. So we're at the end of the for loop. So what happens? The column goes up. So this queen is gone because the method ended. And this column just increases. It turns out you don't actually have to do anything for the backtrack case. You can just allow the method to end. What'll happen is the method for row 2 ends. So I reach the end of the method, which puts us right back here on line 23 for row 1's call, which reaches the end of the for loop, which causes the column number to increment. So for me, honestly, that was the hardest part, figuring out that you actually don't have to type anything for the backtrack case. It actually handles itself. And you can see that if you leave the code just like this and submit, you get a success. So this is the full solution here on the screen. I will also have it on my GitHub, and I'll provide a link to this in the description. Basically, I created a GitHub repository containing all of my LeetCode solutions. At the moment, there are 193 of them and counting. And I believe since I just hit submit on this, it's going to add, N Queens is now here. I just have to move it into the hard folder, which actually, let me do that right now. One moment. Right, that should be good to go if I refresh. Yep, it's now inside the hard folder. Yep, there it is. If I click on N Queens and solution, there it is. So I'll provide a link to this in the description if you want to see the full solution, and you'll also be able to see all of the other problems I've solved on LeetCode so far. All right, so that's it for this video. Benji has joined us for the outro. I hope you were able to follow along. I hope you were able to solve the N Queens problem. If you were, then let me know in the comments. Make sure to subscribe to the channel and like the video if you liked what you saw. And that's it. I'll see you next time.